Welcome to this presentation. Today we are going to learn how to solve simultaneous linear equations by matrix method. The question we have here reads, use matrix method to solve the following simultaneous equations. 4x plus 3y is 18, 5x minus 2y is 11. So the first thing before we continue, ensure that for the two equations, the corresponding terms match. For example, the first term in the two equations are in terms of x and the second term in terms of y. So once that is confirmed, we can continue. We are going to rewrite this system of equations in matrix form. And the first thing is to write the coefficients matrix, that is 4, 3, 5, negative 2, where the elements 4, 3, 5, negative 2 are the coefficients of x and y on the left hand side of the system of equations. Next, we'll multiply that by the variables matrix, and then on the right hand side we'll have the constants matrix. Let's call this equation 1. The next thing, we are going to pre-multiply the left hand side and the right hand side of equation 1 by the inverse of the coefficients matrix. And before we do that, let's get the inverse of the coefficients matrix. The inverse of the coefficients matrix will be obtained as 1 over the determinant of the coefficients matrix times the matrix that will obtain when you interchange the positions of the elements of the leading diagonal, that is 4 and negative 2. So negative 2 will take up the position of 4, so that we have negative 2 right here, and 4 will take up the position of negative 2, so that we have 4 right here. And then for the second diagonal, we'll negate them, that is, we multiply them by negative 1, so that we have negative 3 and negative 5. The next thing is to determine the determinant of the coefficients matrix, and the determinant of the coefficients matrix is obtained by multiplying the elements of the leading diagonal, so that is 4 and negative 2, and that is 4 times negative 2, and then we'll have to subtract the product of the elements of the second diagonal, that is 5 times 3, from that is minus 5 times 3, and 4 times negative 2 is negative 8, 5 times 3 is 15, and therefore we have negative 8 minus 15, and that gives us negative 23. Therefore, the inverse of the coefficients matrix will be obtained as 1 over the determinant, which is negative 23, times the matrix negative 2, negative 3, negative 5, 4, just as we have right here. And this simplifies further to 2 over 23, 5 over 23, 3 over 23, negative 4 over 23. That is when we multiply every element in this matrix by 1 over negative 23. The next thing, we are going to pre-multiply the left hand side and the right hand side of equation 1 by the inverse of the coefficients matrix. So we're going to have the inverse of the coefficients matrix pre-multiplying the left hand side, that is, it comes first and then the equation follows, that is 4, 3, 5, negative 2 for this matrix here, and then xy. And then for the right hand side, again, we are going to pre-multiply by the coefficients matrix. That means the coefficients matrix comes first and then 18, 11 follows. For the left hand side, we have the coefficients matrix and its inverse being multiplied, and whenever we multiply a matrix by its inverse, we get the identity matrix, and because it's a 2 by 2 matrix, we have 1, 0, 0, 1, and then we multiply by x, y. On the right hand side, we are going to multiply as follows. We have 2 over 23 multiplies 18, and then we'll have to add that to 3 over 23 times 11, so that we have that. And then the same thing applies to the second row. 5 over 23 multiplies 18 to get 90 over 23. And then negative 4 over 23 multiplies 11 to get negative 44 over 23. And thus we have 90 over 23 minus 44 over 23 when we add. This matrix here simplifies as 3, 2. And remember, a matrix multiplied by an identity matrix is just the matrix itself. So the left-hand side we have x, y, and then the right-hand side will have 3, 2. This therefore implies that x is 3 and y is 2, just as they correspond in that equation. So x is 3 and y is 2. And that is how we go about this question. Thank you for watching. Hope to see you in the next video. Bye.